From Da Vinci to Da Nang, from Sikorsky to Desert Storm, the helicopter had a difficult start. But today we could not imagine life without them. They're used for just about anything, from swiftwater rescue to special operations, police chases to SWAT teams, insertion of troops to extractions behind enemy lines, news gathering to car chases, construction work to guarding our coast. They even replace tanks on the battlefield. Some can land in the water, and some can even do complete loops like an airplane. But getting there was not easy. This amazing, incredible machine is the result of unrelenting determination, inventive engineering, and man's never-ending fascination with vertical flight. Its evolution from concept to reality spans centuries. Yet today's common sight of the helicopter betrays an uncommon history. A series of events fraught with as many failures as successes, and with several turning points, when the idea of hovering like a bird on the wind seemed all but impossible. In 1490, Leonardo da Vinci drew the first known plan for a vertical flying machine. His helical screw was to be powered by a clockwork motor, and while modern-day experts doubt it would have flown, da Vinci's designs indicate an understanding of the mechanics of vertical flight, and the stage was set for the visionaries that followed. In 1784, two Frenchmen, Lannoy and Bienvenu, create the first working model of a vertical flight machine. Constructed out of a bowstring and some feathers, it actually flew. In 1843, Sir George Cayley creates a small model of his aerial carriage, which he theorized would be powered by an internal combustion engine, which had yet to be invented. But it wasn't until 1903 when the Wright brothers broke the barrier to sustained flight in their fixed-winged aircraft, powered by a combustion engine, that inventors again turned their interest toward the helicopter. In 1907, two French designs broke through the barrier of manned vertical flight. The first, a monstrous four-rotor machine, the Breguet Richer No. 1, lifted its pilot several feet off the ground. This success was followed by inventor Paul Cornu, lifting more than 6 feet in the air with a twin rotorcraft using a 24-horsepower Antoinette engine. Meanwhile, a young Russian named Igor Sikorsky had begun experimenting with helicopter designs, and in 1910 succeeded in creating a working model that was able to raise off the ground. However, control and sustained flight were not attained. Disappointed, Sikorsky turned to designing fixed-wing aircraft and built the world's first 4-engine plane. But his dreams of vertical flight would not be forgotten. As the decade wore on, imaginative, unusual designs proliferated, some with one rotor, others with several, some with intermeshing blades like an egg beater, and others, well, who knows, but they all had one thing in common: failure. Today's helicopters, with their incredible maneuverability, were still only a dream, as problems in stability and control still plagued inventors. But in 1912, the world got another step closer when a Danish inventor named Elhammer devised a method for adjusting the angle of the spinning blades of a rotor, known today as cyclic pitch control. And a Russian inventor named Boris Yorev added the now common tail rotor, which added stability. Like the combustion engine, these two advances would become instrumental in the successful development of the helicopter. With the advent of the First World War, the helicopter took a back seat to the fixed-wing airplane, which soon became a proven asset in battle. It wasn't until the Spaniard Don Juan de la Chiva introduced his autogyro in 1926 that the helicopter again got back on track. Though not a true helicopter, the autogyro was equipped with revolutionary hinged blades which flapped up on the advancing portion of the blade's rotation and then flapped down on the retreating portion of the rotation. A perfect working example of Elhammer's cyclic pitch control. In 1936, Germany's Heinrich Fokker, the designer of the powerful fighter plane, the Fokker-Wulf, introduced the first practical helicopter. The Fokker Oculus FW-61 had twin rotors, each with its own power source, and when piloted by the famous German aviator Hanne Reich, set new records for rotary winged aircraft. Based on the success of the FW-61, the German military ordered the first production helicopter ever, the FA-223 Drache. Due to heavy Allied bombing during World War II, only a handful were ever completed. Watching from across the Atlantic was the once young helicopter pioneer Igor Sikorsky. Having immigrated to the United States to escape the Bolshevik Revolution, Sikorsky had become a major designer of fixed-winged aircraft. But in 1938, he turned his attention back to the problem of vertical flight. In May of 1940, he released the VS-300, forever changing the history of the helicopter. Sikorsky so believed in the success of the helicopter that he insisted on being one of the VS-300's first test pilots. The VS-300 incorporated cyclic pitch control a la Elhammer and Juan de la Cierva, as well as utilizing the rear tail rotor design based on theories of fellow countryman Boris Yorev, thus bringing all the pieces of the helicopter puzzle together in one very successful vertical flying machine.
I remember a good friend of mine and a very prominent designer. When would the helicopter go faster than the airplane? Do you know that? I said, yes, I know. The answer is never. When would the helicopter be more efficient than the airplane? Do you know that? I also said, yes, I know that. Never. But I said that helicopter will do a number of jobs which no airplane will do, and which in fact nothing else will do except the helicopter.
The VS-300 went on to become the R-4, the first helicopter to serve in the United States Armed Forces. Improved versions of the R-4 continued to set records. When the YR-4B descended on the USS Bunker Hill, it was the first helicopter to land on the deck of a ship at sea. It was also the first to be used for rescue when in April of 1944, while operating for the 1st Air Command in the Far East, it picked up 4 downed airmen from behind enemy lines. The R-5 and its civilian version, the S-51, would soon become even more popular, and Igor Sikorsky became known as the father of the modern helicopter industry. By 1947, more than 70 companies were dedicating themselves to the development of the helicopter. The first of these new helicopters to jump out of the block was the Bell 47. First flown in 1945, the Bell 47 was the first successful light helicopter. The design featured the twin-blade teetering rotor with stabilizing bar, which was to become Bell Helicopter's hallmark. The Bell 47 was the first commercially licensed helicopter and soon became the first full-fledged military helicopter. Its primary combat role was as a medevac, and with over 25,000 wounded troops rescued, it soon became known as the Last Chance Taxi. Meanwhile, Charles Kaman, a former employee and protege of Sikorsky, was building the K-125, his everyman's commuter helicopter. It featured twin two-bladed rotors mounted side by side and servo flats that could be trimmed from the cockpit. When Kaman did not receive permission from the CAA to certify civilian production of the K-125, he decided to turn his attention to agribusiness and built the popular K-190.
Here comes the Cayman 190, a new star on the helicopter horizon. This job has drawn special interest in aviation circles, for many observers feel that helicopters have a big future as air flitters. Here's the plane and fancy fuselage for tomorrow.
Kamen then revolutionized the helicopter industry when he installed a Boeing turbine engine on his next model, the K-225. Turbine engines were much lighter than piston-driven engines and could be mounted above the cabin of a transport helicopter, allowing for more room inside. They were also stronger, smoother, and quieter than conventional engines and would have a major impact on the industry. Kamen continued to have great success during this period with derivatives of the K-225, including the HOK-1, a marine observation helicopter, and the HTK-1, a naval training helicopter. They soon evolved into the H-43 Husky. These helicopters were used primarily by the Air Force for crash and rescue. They carried personnel and were known for their firefighting ability, transporting portable extinguishing systems which were revolutionary for crash and rescue firefighting. Bell and Kamen continued to have great success during the 50s, but they were not the only players now, as across the world, new helicopter manufacturers came onto the scene. Aerospatiale, Augusta Spa, Boeing, Vertol, Hughes, McDonnell Douglas, Westland, Hiller, and perhaps most importantly, the Soviet Union. Soviet helicopter development of the era was spearheaded by three men, Mikhail Mil, Alexander Yakovlev, and Nikolai Kamov. The Mil Mi-4, very reminiscent of the Sikorsky S-55, set world records for altitude and speed. Its latter versions became the Soviet workhorse for both military and domestic use. Yakovlev contributed the Yak-24 horse, the largest helicopter of its time. This dual-rotor monster had a cargo area nearly 30 feet long and 6 feet wide and high. The Yak-24 could hold up to 40 passengers. While both Mil and Yakovlev designs mirrored much of the designs of the West, Kamov was busy perfecting a coaxial contra-rotating rotor system, as seen on these Ka-25s, a design the West had often shunned. As with all the elements of the Cold War, helicopter development was spurred on by the opponent's successes. The U.S. answer to the Yak-24 was the Piasecki H-21 Shawnee. Used by all branches of the military, it was affectionately known as the Flying Banana. The Shawnee was used up and until the early stages of the Vietnam War, when Boeing Vertol, who had purchased Piasecki, introduced two new workhorses which continue to this day, the Navy Marine CH-46 Sea Knight and the Army's CH-47 Chinook. In 1961, the U.S. Marine Corps ordered the CH-46 to fill its need for a medium-range assault transport, and the Navy ordered its own variant, the UH-46A, designed for vertical replenishment. The Sea Knight was equipped with two General Electric turbine engines, which produced 1,250 horsepower each, powering the twin-bladed counter-rotating rotors.
The primary mission of the H-46 when we embark aboard ship is to transport combat-loaded Marines from ship to shore in an amphibious type of an operation.
The Sea Knight can hold 25 fully equipped combat troops, and its wide rear loading ramp is used for deployment and retrieval of troops, cargo, or heavy machinery. The Sea Knight particularly shines when operating near water. With its sealed cabin, the Sea Knight can operate at the ocean surface, even landing in the water, making it ideal for troop insertion and extraction and for search and rescue. While the CH-46 prospered on the ocean, the CH-47 Chinook dominated on land.
Although the 46 and the 47 look alike, they're both made by Boeing, they're both tandem rotor, but the 47 in terms of mission is a lot more like a 53. It's a heavy lift platform. So really we see the similarity in there.
To meet the Army's new requirement, the CH-47 needed to hold 40 combat troops and carry up to a 16,000-pound external load. The first Chinooks were powered by two Lycoming turboshaft engines, producing a whopping 2,650 horsepower. Like the Sea Knight, the bottom of the Chinook is watertight to allow it to operate at water level. By 1965, both of these awesome troop transports were in use in Vietnam. They performed so well that when the time came for the U.S. military to upgrade its helicopter transports, they decided to modify the existing 46 and 47 instead of looking for a new design. The upgrades continue to this day with features that include night vision, more powerful engines, and digital state-of-the-art cockpit.
46 has been around since the Vietnam era. The Marine Corps has spent significant amounts of money upgrading it through the years and keeping it up to standards. It's a workhorse. It flies every day, lots of hours, and it still performs very admirably day to day.
Perhaps the most exciting use of the Sea Knight and Chinook are for special operations.
There are standard missions in our community, and there are what we call special operations capable missions, which many of those do involve working with reconnaissance forces to do special insertion extraction technique, also known as SPY. We can do gas oil platform takedowns, and again landing in all weather conditions and at night on night vision goggles.
In 1961, Sikorsky delivered the first of a new generation of amphibious helicopter to the Navy. The S-61, designated by the Navy as the SH-3 Sea King, was specially designed as an anti-submarine warfare helicopter. This large multi-purpose helicopter was powered by twin General Electric turboshaft engines, supplying 1,250 horsepower to its 5-bladed main rotor. The unique boat-hold design of the fuselage ruled out any doubt that this bird was indeed capable of operating in the water. Later used as a troop and VIP transport and for search and rescue, the S-61 was so successful that, like many of Sikorsky's other designs, proliferated to every branch of the U.S. Armed Services. As of summer '99, the U.S. Navy continues to fly only 52 H-3s. Used primarily within the Battle Group Command, the H-3 is viewed by some with nostalgia as a 39-year-old workhorse used for plane guard, vertical replenishment, VIP transport, and search and rescue. The H-3 is the only mid-range transport helicopter that can touch down on water in an emergency or operational scenario and not sink.
It floats. In an overwater aircraft, that's a pretty nice thing to have. Out of all the naval helicopters operating right now, the H-3 is the only one that I know of that floats consistently.
A concerning factor when transporting VIPs and all high-ranking military commanders over great distances of water during war or peace. It is of so much concern to the United States Marine Corps that they ensure us that until a more worthy transport becomes available, the Commander-in-Chief of all U.S. Armed Forces will continue to use an H-3 as Marine One. Pretty amazing for a 40-year-old aircraft. But that was not the end to Sikorsky's amphibious vertical transport development. Civilian operators wanted to lift more tonnage and still retain the safety of a boat-hold bottom craft. The result was the civilian S-61R, popular for passenger service in areas such as New York, Los Angeles, and San Francisco. The S-61R was based on a modified and extended H-3 chassis. For the U.S. military, Sikorsky further modified this new amphibious design with several improvements, including a rear loading ramp, wider hull sponsons, which increased fuel capacity and afforded better stabilization on water touchdowns. The U.S. military S-61R was delivered in 3 configurations: the Air Force's HH-3E Jolly Green Giant, Navy Marine Corps' HSS-2, and the U.S. Coast Guard's HH-3F Pelican. Although Navy Marine HSS-2 saw service for specialized operations such as ferrying explosives and diving equipment, it was slowly phased out by the advent of the Boeing CH-46. Without any doubt, the most famous of the series were the Air Force's Jolly Green Giant and the U.S. Coast Guard's Pelican. The Pelican was equipped for search and rescue with highly advanced navigation equipment. The Pelican fleet served admirably with the United States Coast Guard in its capacity as a long-range search and rescue unit, saving over 23,000 lives. Should the Pelican have to touch down at sea for a rescue, it was equipped with a removable fold-out rescue platform at the main door. The large extended step would slope beneath the water surface from the main door, making the recovery or rescue of victims easier. From its earliest beginnings to today's technological marvel, the helicopter has continued to enthrall and amaze us, and it's certain that the future will bring us even more amazing, incredible helicopters.